In this section, we're going to discuss about the conjugate of a complex number. So if we have a complex number z, then the conjugate is denoted by z with a bar on top of it. So what it means, that if we have a complex number z given by a plus ib, then its conjugate, which is g bar, simply going to be a plus ib over bar. So that means when we are talking about the conjugate, what we do, there will be no change to the real part. So the real part of z bar is a, so it will be written as a. Now what we'll do, we will now transform the I to a negative I. So we'll have negative ib, so that means that the conjugate of a plus ib is simply a minus ib, and we have replaced I by a negative I. Let's do an example. So if we are given the complex number z is equals to 2 plus 3i, then the conjugate of the complex number z will be simply 2 minus of 3 of I. Let's take another one. So let's say we have another matrix, why do I keep on saying it as matrix? This is another complex number, negative 2, negative 3i. Then its conjugate will be simply negative 2 minus negative I with a bar over it, and that will be simply, it won't be plus 2, it will stay as negative 2. There will be no change to the real part. Only change will be that we get replaced by negative I, since we have I here, so this will be negative I, and that gives us negative 2 plus 3 of I. So this is the conjugate of z1, which is negative 2 minus 3 of I. Now let's talk about some properties of conjugates. So we'll discuss about a few of the properties. The property number 1. So if we have a complex number z, then z equals to a plus ib, then the conjugate of its conjugate is the original complex number. So let's find out. So if we find a z bar, so that is going to be a minus ib. So let's call it z1. Now we're going to take the conjugate of z1, which is simply a minus ib bar, and we replace the I by negative I, so that becomes a plus ib, which is giving us the original complex number z. So we have z bar is equals to the original complex number. So complex of a conjugate of a conjugate gives us the complex number. Now we go to the second one, which is a complex number when added to its conjugate gives us the 2 times the real part of z. So let's assume that z is equals to a plus ib, such that its conjugate will be a minus ib. Then we add both of them. So z plus z bar is equals to a plus ib plus its conjugate, which is a minus ib. Now we can see that ib and negative ib are additive inverses of each other. So we cancel it out, then it leaves us with twice of a, and this is a purely real number. So we have 2 times a, and 2 times a is what? Which is the real part of our complex number z. Let's check what happens when we subtract them. So that will be property number 3. Let's see what z minus z bar is going to give us. So we begin by substituting the value of z as a plus ib minus its conjugate, which is a minus ib. So that gives us a plus ib minus a. Then we have a minus multiply to a negative IB, so that will give us a positive IB. Now we'll see that A is the additive inverse of negative A, so it's going to cancel out, leaving us with 2 times of IB. So this is a purely imaginary number. Or in other words, we can say that this is 2 times of the imaginary part of our original complex number Z. So when we subtract the conjugate from a complex number, then we get 2 times the imaginary part of our complex number Z. Then we talk about property number 4. Property number 4 is if our complex number Z is equals to its conjugate, then what can you say about the complex number Z? Let's find it out. So if Z is equals to Z bar, so let's assume that Z has the value A plus IB. So which would imply that its conjugate Z bar will be A minus IB. Let's equate them. That is A is equals to Z bar. So we have A plus IB equals to A minus IB. Then we can cancel out A from both sides, so that leaves us with IB equals to negative IB. We have IB plus IB is equals to 0, which is twice of IB is equals to 0. So we know that 2 is a number. 2 cannot be equals to 0, it being a number. I is also a number which cannot be equals to 0. The only way this equation is going to be valid if we consider B to be equals to 0. That is the only possibility. Now let us substitute this value of B equals to 0 into a complex number. So that gives us Z is equals to A plus I times 0, which is A. So that means we only have, this is a purely real number. So that means we only have the real part of Z. So that means whenever the complex number Z is equal to its conjugate, then it implies that Z is a purely real number, which will be equals to it A. So this is property number 4. Let's talk about property number 5. So property number 5, we check if Z plus Z bar is equals to 0, then what does it imply? So there are two ways to check it out. We have already done property number 2. So property number 2 was Z plus Z bar is equals to 2 times the real part of Z. This is our property number 2. Now here it's given that this is equals to 0. So that means what? 2 times the real parts of Z is equals to 0. 2 being a number cannot be equals to 0. The only way it's possible if the real part is 0. So that means the value of A is equals to 0. So that means Z plus Z bar is giving us only the imaginary part. Only the imaginary part. So let's check out what's the value of this imaginary part. So we consider Z is equals to A plus IB, and its conjugate will be A minus IB, and we are going to add both of them, so that gives us twice of A. And they're saying that this value is equals to 0, which implies A is equals to 0. So therefore the value of Z is equals to 0 plus I times B. So that means Z plus Z bar is equals to I times B, and that is the imaginary part of a complex number Z. So property number 4 stated that if Z is equals to its conjugate, then we have a real part of Z. And this property states that when we add a complex number to its conjugate, if the answer is 0, if its answer is 0, then this gives us that Z is equals to the imaginary part of Z. Let's go to property number 6. This is a very important property. Let me give a star to it. Let me give 2 stars. So property number 6 states that if we have two complex numbers z1 and z2 and add them and then take its conjugate, then it is equals to the conjugate of z1 plus the conjugate of z2. So let's try to prove this one. The proof. So let a complex number z1 be denoted by a plus a1 plus I times b1, and a complex number z2 be denoted by a2 plus I times b2. Let's take the conjugate of z1. So that will be simply a1. We replace I by negative I, so that will give us negative I b1. And similarly, the conjugate of complex number z2 will be a2 minus I times b2. So this is the one. Now we start with the left hand side, which is z1 plus z2 and its conjugate. So let's add z1. So we have a1 plus I times b1 is added to a2 plus I times b2. And then we have to find its conjugate. So let's work out with the addition. So we're not going to work with the conjugate term first. So first let's have a1 plus a2 plus I times b1 plus b2. Now we take the conjugate of this new added value. So we have a1 plus a2, the plus I will become a negative I, that's the conjugate, times b1 plus b2. Now we're going to separate it. So we have a1 plus a2 minus ib1 minus ib2. Now we're going to combine it. We have a1 minus ib1 plus a2 minus ib2. Now we have already found out that a1 minus ib1 is z1 bar, so we have z1 bar plus a2 minus ib2, which gives us z2 bar. So that means when we have two complex number, we add them and take the conjugate. This is equivalent to saying that we first find out the conjugate of each of them and then add each other. That will give us the same result. The next property is similar to this one. So if we have property number 7, if we have z1 and z2 as two complex number and we find out z1 minus z2 and we take the conjugate of it, then this will be equivalent to z1 bar minus z2 bar. I'll leave this as an exercise for you to try out. This will be similar to previous one. You can assume z1 to be a1 plus ib1 b1 and z2 to be a2 plus ib2, and you can follow the steps which we have done for z1 plus z2 bar. So here you'll get the same result. Let's go to property number 8. So property number 8, this is a very important one. We take a complex number and then multiply it to its conjugate. Let's see what it gives. So let's say proof. We need some space here. So let us consider that our complex number z is given by its standard form a plus ib. Then we take its conjugate, which will give us a minus ib. Now we're going to multiply it. So z times z bar is going to be equals to a plus ib multiplied to a minus ib. You can go ahead and multiply using the FOIL method, but I'm going to apply the identity that x minus a times x plus a is equals to x squared minus of a squared. So we have x, which is equals to a here, so we'll get a squared minus a, which is I times b, so we have I times b whole squared. So this gives us a squared minus I squared times B squared, and we know that the value of I squared is -1, so times B squared, and that gives us finally A squared plus B squared. So that means Z multiplied to its conjugate gives us A squared plus B squared, which is going to be a purely real number. This is an extremely important property, and we will encounter this very often later when we start solving problems. Now let's talk further about the other properties. So let's say we have, this is property number 9. So we have talked about addition and subtraction. Let's talk about multiplication. So we have two complex numbers z1 and z2. We take the conjugate of them. That will be equivalent to z1 bar times z2 bar. Again, I'm leaving the proof as an exercise for you to try out. Similarly, for division, we have z1 divided by z2, and we take the combined conjugate of it. That is equivalent to saying we take the conjugate of z1 and divide it by the conjugate of z2. So this completes all the properties of the different properties of the conjugate of a complex number. We'll be doing some problems very soon.